Hello, everybody, and welcome back to another Mr. Farney Earth Science video here as part of our earthquake unit. In our last video, we spoke about just like earthquake basics. We learned some terminology about different stressors that are applied to faults, the direction of the movement because of those stresses, and a few other fun terminologies kind of thrown into the mix just to get us all thinking about earthquakes, what they do, how they work. In this video, we're speaking about seismic waves, the waves that are generated by an earthquake. Now, if we take a look at the picture that we have here, this shows us how those waves kind of radiate out from a location that we refer to as a focus. Now, this focus is the underground point or the underground position on that fault line that gets stuck. Yesterday, we did the example where we interlocked our fingers and we try to pull them apart without letting go. That sticking point that we've created with our fingers, that's essentially the focus that we see that gets stuck on that fault line when both sides, both parts of the crust opposite of that fault try to move. That's the focus, it's underground. The epicenter that we hear scientists use that word all the time, where is the epicenter of the earthquake? It's located X, Y, and Z. That's the surface point directly above the focus where the earthquake's origin is located. So epicenter is on the surface. The focus or the exact point where that catching or where that tension is building up, or that stress, I should say, is building up, is located underground. So we have focus, we have epicenter. Again, there are different types of seismic waves that we're going to talk about with earthquakes. The first one we refer to as a primary wave or the P wave. This is a wave that's formed from compression and expansion of material as it travels through any sort of material. That's solids and that's liquids. These are the first waves to reach a seismograph after an earthquake. That's why they call them primary. They're the first ones to get there. They're very fast moving. And because of this push-pull motion, it's almost like they're snaking underground through that material as it kind of moves past different locations. This picture, it doesn't do the best job at kind of figuring out what's happening as far as P waves go. But if you look at my little black box here, if this black box were to move kind of the direction of propagation, or that's the direction of flow through this material, it would go a little bit forward, and then it would kind of go back a little bit, and then go a little bit forward, and then a little bit back, and just kind of snake all the way through this material. It's kind of like that scene in Willy Wonka where he takes 2 steps down and 1 step back when they're in the candy factory at the very beginning of the movie. That is what P waves are kind of doing. They're moving forward a little bit, then back. They're expanding and compressing through some sort of material. That is P waves, our primary waves. The next wave we're going to talk about are the secondary waves. There are S waves. They're the second waves. They only travel through solids. They're not going through liquids. They're not going through any sort of gases. These ones move side to side. They arrive secondary to seismographs after the P wave. That's why they're called secondary waves, because they arrive second after the P wave. Another way to kind of remember how they move, secondary starts with an S, side to side starts with an S. So these are kind of going back and forth underground through some material. So if we're looking at this picture here, it's kind of hard to see. But as our little black square kind of moves the direction of flow here, the direction of propagation, it's going to go kind of like up and down, just like this, kind of creating a wave as it moves through whatever material it's moving through underground. We need to kind of keep that in mind, that our P waves and our S waves, our primary and our secondary, these are body waves. These are waves that move underground. They're the ones that let scientists begin to figure out what the different layers of Earth are made out of. So my P waves are primary, my S waves are secondary. They're both underground. They both move through different types of materials. My surface waves, these are the more dangerous ones. These are the ones that create the destruction that we see on TV, that we have had evidence of. They come after the P and the S waves. These are our love waves or our L waves. and the Rayleigh waves or the R waves. They're the slowest but most destructive. These ones move side to side and they move up and down, depending which wave we're talking about. If we're talking about the love wave, we're on the surface now. So you'll notice in this picture, my little black square, it's no longer on the side, it's on the top. So as this one moves the direction of flow here, it's going to go on the top and it's just going to move side to side, just like this. Very slowly, side to side, almost creating a very similar wave pattern to my underground S wave. They're just kind of snaking as it goes through. That's our love wave. It moves side to side. Let me clear that off real quick. And then go to the Rayleigh wave. My Rayleigh wave, these are going to create waves on the surface that are almost like ocean waves. So my little black box, again, it's on the side of this, but what it will do with the surface material is as my little black box moves the same direction we've been doing, it's going to create these little like ocean waves of material as it goes through the surface. We see that the particle motion here is kind of like this backwards hooking. That is the motion that this material is doing. That's why it kind of creates that wave pattern. So my love waves and my Rayleigh waves, they both have different types of motion, but they're both located on the surface. So P and S waves are underground, primary and secondary. My love and Rayleigh waves, my L and R, they're on the surface. Here's another picture of all of these waves just kind of showing how they move. My P waves is that kind of pressure wave going through the material, indicated by this black line. My S wave, it's kind of waving back and forth. That's why we have the material kind of bending in this picture as it moves. My surface wave, it's going back and forth, indicated by the arrows here. My love wave, my Rayleigh wave, it's making kind of that ocean-like wave as this shock wave moves through whichever material. So it's very important to, one, know the difference between my body waves and my surface waves, my waves that are underground and my waves that are at the surface, and then the type of movement that they're doing. So it's a lot of information to kind of take in about these 4 different seismic waves. How do we measure them? Scientists use a seismograph. It's a weight that has a pen connected to it that touches a piece of paper and it's attached to a spring. It's very sensitive to any sort of vibrations. And if a vibration happens, it'll start kind of moving back and forth. That pen touching this rotating drum will draw a line indicating any sort of reverberation in the surface. The wave that reaches the seismometer first is always the P wave. It is the primary wave that reaches first, followed by the S wave. Scientists use the difference in time. And let me get my little marker here. The difference in time between the P wave and the S wave, this time right here, whatever this difference is. So the difference between the P wave and the S wave, the difference between those two, they use to figure out how far they are. I'll just make my own random little equation here. The difference between P and S is the distance that seismometer is from the focus or from the epicenter. You need 3 different locations to be able to triangulate where that epicenter exactly was. You can't just use it from one station. We'll talk more about this, I believe, in the next video, but we can always introduce it here. We'll get back to, triangulation later, but just recognize that the P wave arrives first, the S wave arrives second, and that all of that is then followed by our slower, more destructive surface waves. And we can see just the undulation between the P wave and the S wave, not so much, but in the surface wave, so much more movement as diagrammed here on my seismograph. So P wave, S wave, time. This is a time curve that scientists use to show how far they are from an epicenter. And they use that difference in time between the P and the S wave, like I said, to figure that out. The further the epicenter is away, the greater indifference in time arrivals between that P wave and the S wave. If they arrive very close to each other, that means you're very close to the epicenter. If there's a big difference in time between my P wave and my S wave, you know you're further from the epicenter of that earthquake. And it's knowing not only how far you are from the earthquake that gives some scientists some very useful information, but it's the type of waves that they're receiving. Because if an earthquake happens and a scientist is like on the opposite side of the planet, and they're only picking up maybe primary waves, but no secondary, that's giving them, some interesting thoughts as to what's going on underground where I'm not getting both of these waves. This is the thought process that led scientists to start using seismic waves to studying the different layers underneath the earth. That's why it's not the same all the way through. Remember, in times of Alfred Wegener, people thought the planet was solid all the way through, and they couldn't explain how these large continents were moving through each other. We now know, because of our seismic studies, that the crust is solid, our asthenosphere is like a semi-solid. We have a liquid outer core and a solid inner core. And we know all of this because we've been studying how these seismic waves emanating from a focus of an earthquake are interacting with these different types of materials underground. So again, focus versus an epicenter. Focus is underground. Epicenter is the point directly above the focus on the surface of the planet. Here's our last slide that we're going to talk about today. Again, just giving a little more information about seismic waves, about our P and our S waves. So that seismic waves, we know it moves away from the focus. My P waves, they move through solids and liquids. And then my S waves, they only go through solids. So that's why we create these random little zones on here that we see that are black arrows, which are our S waves, are located only on the same side of the planet as the epicenter, because our outer core, our liquid outer core, is blocking them from being able to penetrate and go out the other side. So it kind of creates these zones opposite of the earthquake where you're not going to see S waves. Information like this, amongst others, is how scientists were being able to begin to glean the types of materials that they are dealing with underneath the Earth's surface. Very interesting stuff. So that's a lot of information thrown at you real quick about our different types of waves, our P waves, our S waves, our surface love waves, and our Rayleigh waves. Whole bunch of stuff. So I really encourage everybody to kind of go back, double read through the notes, take down some good differentiating information about these different waves so you will not be confused. You'll be in really good shape when you see this pop up on a quiz or a test. So if you have any questions for me, please go ahead, reach out, let me know, ask. I will unstuck you like our focus does, creating earthquakes, and I'll see you again in the next video. Have a great rest of your day, and we will see you next time.